Okay, we have another example of a Faraday's law problem here, where we have a uh, wire with some resistance in it. It's in a uniform magnetic field. The thing that's interesting about that magnetic field is that time t equals 0, it's 0. The magnetic field is increasing for a while, then it's uniform at 4 Tesla, and then it decreases and actually goes negative eventually. They want to know the magnitude of the current induced around the wire loop at 5 seconds, so right at this point here. I think the thing we need to realize is that at t equals 5 seconds, the magnetic field is decreasing, so there is a change in flux, and that change in flux is going to create an EMF around the loop. That EMF can give us a current. So let's go ahead and do the math. So we start with seeing how fast our flux is changing. Flux is just the magnetic field times the area of the loop. The area of the loop isn't changing, but B is changing. So we're going to need to calculate dB dt. It's just the slope we have there. And once we have that, we'll have the EMF, and from that we can get the current. So in this case here, we see that the flux is changing by changes 4 Tesla over changes by 4 Tesla here, from 4 to 0 in 2 seconds. So the rate of change is minus 2 Tesla per second. And so we can go ahead and plug that in to our expression for the EMF and divide by the resistance and go ahead and get the induced current.